And finally, for WordPress, you will find a plugins manager that allow you to install plugins to your websites. So now we will focus on how to design a pluggable application. So first of all, you need to design a main application, which I will call it a platform. It will provide some core features and basic functionalities. And you will find also some plugins which are like a micro application. They are small. And these plugins will consume an API which is provided by the main application or the platform. So API, we will find like data access API, a logger API, security manager API, etc. And at runtime, these plugins will be lazy loaded to your platform, so the user can install it and load them at runtime. From other side, an application have two layers, have the front-end layers and the back-end layers. So your platform or your main application could have a front-end layer and the back-end layer, and also your micro app or your plugin could have a front-end layer also or a back-end layer. So by designing this kind of application, you will provide something, I will say it's valuable work. So your application can behave differently based on plugins which will be installed by the users, and developing the platform or the main application will be loosely coupled from the life cycle of developing plugins. So also third parties, developers can extend your application and can develop their own plugin and plug it to the main application, like we do with VS Code, for example, Eclipse, or WordPress, or other example. And your features will be delivered into a small piece of code, which are small plugins that you deliver. You can deliver every month new features to your users, package it into plugins. So to develop this kind of application, there are some requirement to provide. We can find, first of all, how to runtime lazy load these different modules. Also, you have to provide the inversion of control principle into your application or into your platform. So you provide an API. The real implementation will be in the platform, and this API will be consumed by the different extensions and plugins. And also, like every pluggable application, there should be some specific bundling and packaging tool or contract. So you have to write a contract how developers can extend your application and develop his own plugin. So we will focus on these two technology or the frameworks. We'll focus on the client side on Angular, and in the backend on Node.js. So first of all, does Angular provide a lazy loading mechanism? The response is yes. It's a route-based mechanism. It's an out-of-the-box feature, but it requires build time dependency. So today you can develop a lazy loading application with Angular, and you can lazy load some modules at runtime, but you have to provide these modules at build time. So Webpack will generate the specific code that will lazy load this plugin or this module at runtime. So you will say you can package your plugin as a web component using Angular elements. So the response is yes. Maybe we can wrap our plugin or extension as web components using Angular elements, and it's build time independent, so every plugin or extension can be built separately. But you cannot use the dependency injection mechanism of Angular, so you cannot inject a shared API from the core platform into your extension components. And what about inversion of control? So Angular provide dependency injection mechanism. So every services in Angular is injectable. So the inversion of control is provided in Angular. And what about bundling and packaging? So bundling and packaging in Angular app, you have many options. You can use Webpack, Rollup, ng Packager. There are a lot of tools that help you bundle and package your Angular app. So to sum up, Angular provides inversion of control and provides specific bundling and packaging tools, but the lazy loaded mechanism provided by Angular doesn't fit our expectation. And what about Node.js? So Node.js is modular. So you can call require everywhere in your code, and Node.js will lazy load your module at runtime. And what about inversion of control? So in Node.js or JavaScript, there are no inversion of control principle provided out of the box. And for bundling and packaging, you can just use npm pack or yarn pack, but also you can use some gulp task to minify and uglify your JS code. So for Node.js, we have runtime modules loading, but we don't have inversion of control, and we have bundling tools provided. So we have to work into two concepts. We have to provide some handcrafted solution for runtime lazy loading in Angular and inversion of control in Node.js. First of all, we'll start with lazy loading in Angular. So our solution was to use ng Packager. So we have our plugin or our extension which will be packaged using ng Packager. So ng Packager is a library that help you build and package an Angular app as a library, and it was included into Angular CLI 6, and till now it's included. So using Angular CLI, you can create libraries today, and they will be packaged using Angular ng Packager. So ng Packager, you have just to fill this configuration, and you will get these different bundles generated. So your Angular app or micro app will be bundled as a UMD.js module. Now that we have packaged our plugin as JavaScript module, we need to lazy load this module at runtime. So we need some JS loader, and we have found that system.js fit our expectation. Is simple. So we just call system.js.import at runtime, and you will get this JavaScript file, which will be deployed into private CDN or installed in your server. And after that, when you get your module, you have to call the Angular compiler, which is embedded in the main application, and this Angular compiler will compile the lazy loaded module and create an instance of your entry point, and will inject it into the view using the dynamic view child mechanism. So now, using system.js and Angular compiler and ng Packager, we have resolved the issue to develop a plugin separately and build it separately, lazy load it at runtime, and using the same core dependency injector to inject our API into our plugin. Now let's move to Node.js. So after doing some research about how to implement inversion of control in JavaScript, we have found Inversify.js, which is a library based on TypeScript. It's a powerful inversion of control container. So it's allow you to create some classes that implement some interfaces, decorate your classes with injectable, and you can inject your class everywhere. So, and also it provides an extension which is called Inversify Express Utils. So when you are using Express server, you can create your REST API using Inversify Express Util, so you can create your REST API controller as a class, TypeScript class, decorated with Arrowbus controller, and every method, you have also some decorators for HTTP method. And at runtime, when you load this controller, Inversify will register this new endpoint into your Express routes. So for developers that have used it before Spring Source in Java development, or they have Java background, they can feel comfortable when they use Inversify in Node.js. Now that we have TypeScript, inversion of control, RxJS in the front-end layer, and in the backend you have TypeScript and inversion of control also. So I recommend to complete this stack in Node.js by using also RxJS and make it reactive. So to use RxJS into your Node.js application, you have just to convert your callback function using myNode callback operator, and you can enjoy using pipes operator in your Node.js application, and your application is reactive. So now I want to switch to a small demo on how it is, how we do lazy loading and what does it mean using lazy loading at runtime. So we have this application. It's simple, just for demo. We have this marketplace, and this app will request npm JS registry, and it will load every modules that have some keywords, specific keywords for Odessa.js 2019 event. So we have an extension that is already deployed. So we simulate that we have developed our plugin and deploy it to npm registry, and we will click into install and load, and we will see what's happened in the browser. So this is the network. So by clicking on install, there are an install request that is that calls the backend API to install this plugin from npm registry, and the response was the entry point of this plugin, which is Odessa 19 plugin image umd.js file, and at runtime the front-end layer have requested this Angular module and compiled it and instantiate the entry point of this module and inject it into our view. And this is what we call runtime lazy loading, because we have an external resource that we have loaded at runtime and injected. So we have a workshop at 3 p.m. today. So you can join the workshop to look deeper on how to implement a plugin and how to package this plugin, publish it into npm registry, and lazy load it in this application. And also we will focus on the code that is written on how to lazy load plugin client side and server side in Angular and NodeJS. And thank you for your attention. Okay.